Okay, so good morning, everyone. So in today's class, we are going to cover three topics, that is classification, life cycle, and data set. So by classification of machine learning, I mean that how many categories of machine learning actually are. Okay, so by classification, you can also mean that the types of machine learning. Okay, so life cycle of machine learning means when you make your machine learn something, so there are certain steps that we follow from the beginning till we make our machine learn something. So there are certain steps that we have to follow. That becomes the life cycle of machine learning. Okay, and I told you that whenever you make your machine learn something, you give the learning capabilities to your machine. So how you do that? It's not like that you are feeding them with intelligence. No, how your machine will get the intelligence? You actually feed the data. Okay, so data is a kind of intelligence that you put into your machine. So what is the data? What are the data sets? What kind of data you can feed into your machine, and from where you can get that data? You can create your own data, or you can fetch the data from online resources that we will cover in the data set part. Okay, so just to summarize, classification means we are going to cover the types of machine learning. Life cycle mean the steps through which your machine will go when we make it learn something, and the last one is the data that we feed into the machine. We will get a very detailed overview of it. So without wasting any time, let's start. So this is an overview. I have told you about it already. So first of all, we will cover the types of machine learning, then machine learning life cycle, and then data set in machine learning. So these three topics we are going to cover today. So first of all, we will cover the very first topic, that is types of machine learning. Okay, so types, you can also say classification, as you have, I guess, already studied it in artificial intelligence, that the machine learning is actually, it is of three types. Okay, so the three types are the supervised learning, unsupervised learning, and reinforcement. So we were discussing about the types. So there are three types: supervised learning, then there is unsupervised learning, and then there is reinforcement learning. There are total three categories of learning. Okay, so we will discuss all these three categories next, and I will give you that a very brief idea about it, and whenever there is need, I will ask you the questions. Okay, so classification of machine learning. So you can classify it as this figure has already classified it. So there are three categories into which you can classify your machine learning. It is supervised learning, unsupervised learning, and reinforcement learning. So first of all, what is supervised learning? Okay, so without looking at this slide, I just want to give you an idea that what a supervised learning is. So whenever I teach the students about supervised learning, so I always help them remember it by giving them an example of a supervisor. Okay, so suppose you have a supervisor with you all the time. When you come to college, you are learning something. Okay, so who is your supervisor? Your teacher is your supervisor. So super means some person who is at a better level than you, right? Maybe in intelligence, maybe in knowledge. Okay, so he or she can guide you, supervise you. So whenever you are doing something, that person is always keeping a close check on you, that whether you are doing things right or not. And wherever you are wrong, that person is available to pinpoint you and tell you that you are doing something wrong and you can correct it. Okay, so your teacher is a kind of your supervisor. Okay, and you as a student, you are working, you are learning, you are grabbing things under the supervision. Okay, so the supervisor is giving you his supervision. So why you need that supervision? You are in the learning stage, you are learning things. Okay, so while learning things, there are chances that you make some mistakes. You are, suppose in our class, you are solving certain numerical or you're doing coding. Okay, and there are chances that you might end up with an error. There is some error that you feel is coming in your code. So at that time, from which person you will seek help? So you will always look up to your supervisor. So you will call your supervisor, your teacher, and tell him or her that this is the problem that you are facing. So what will be the next step? The next step will be that your supervisor will correct that issue. He will give you certain suggestions. He will tell you that you can change this, you can change the code over here, and then you might get the output. So it means under the supervision of your teacher, you may correct your code and you will get a proper output. It means you will get your desired output. Okay, so in case of, this is a normal scenario, this is a real life scenario, but in the machine learning language, okay, so this student is replaced by a machine. Okay, now your machine is learning. In classroom you are learning, but in the machine learning, who is learning? Your machine is learning. Okay, so this is a machine, you are making it learn things, certain things. Okay, and here there is no supervisor, there is no teacher, physically there is no one present. So who is doing the supervision? Who is guiding your machine? Who is making your machine learn things? So the answer is data set. You have data set. Okay, so this data set you feed into your machine. As I gave you an example that the data set has 2 columns. It is made up of area and prices. So you know that for this area, this is the price, this area, this is the price. You want that your machine should also know this thing. So what will you do? You will feed this data to your machine. So when you feed this data into your machine, now your machine also knows that for particular area, what will be the price. It means you are making your machine learn. Okay. And next time you are giving it a fresh new area to predict the price. So who will be guiding your machine to predict the price? This same data, because this data is being fed into your machine. For particular area, the prices are being fed. So now your machine is ready to make hints under the supervision of this data. So this data set is acting as a supervisor in case your machine is learning. As when you are learning, your teacher is there to guide you. So the same thing that I have explained, it is mentioned in this slide. Okay, so you can see that in the very first line, it is written that supervised learning, it is a type of machine learning because it is a category. We are classifying, so it is a type of machine learning method in which we provide sample labeled data to the machine learning system. Okay, so if we are giving it a sample, okay, and our data has labels. You agree or not? Whenever I am giving the data, so suppose my data is numerical data, 2200 and 5,650. So this data has no meaning until and unless I will give it some label. So what is the label? That this is area, this column has label area, and this column has label price. So now my data has got the meaning also. Okay, so this label data we provide to our machine learning system. Why? Because we are training it. We are giving the training so that our machine should learn. Okay, and on the basis of that training, yeah, now your machine is ready to predict the output for a fresh new data. This thing I have explained you. Okay, I'm repeating it. Supervised learning is a type of machine learning method in which you give the sample data, and that data should be labeled to the machine learning system, means to your machine. And why? In order to train it. And on that training, on that basis, you ask your machine to predict the output. Okay, so your machine actually use that data and it creates a model to understand the data sets. Okay, so in the last example, in yesterday's example, what we decided that the model will be linear one on the basis of this thing, that the points are coming very close to the line. So we say that it can be linear regression model. And then after saying that this will be the model, it start learning about each data. And once the training and processing are done, once you train it, once you decide the model, you train the data, you provide it to your machine, then what we do after training, we test our machine. We test it by giving it sample data. Okay, so to check whether it is predicting the exact output or not, I am giving you training. I'm telling you, for example, in this class, I'm telling you what is supervised learning. So I'm training you. I'm giving you the information. Then the next step is I will test you. How I will test you? Randomly, I will ask you questions. I will ask question from Lakshmina. I will ask question from Ravneet, from anyone. Why? Just to test you that whether my training is valid, whether you are learning something out of it or not. Okay, the same process we are doing with the machine. Your machine, you are providing it data, you are training it, and then you test it by giving it new data and check whether it is predicting the value or not. Okay, so what is the goal of supervised learning? It is to map the input data with the output data. So you gave it input to predict something, and what you want the output. Okay, and it is based on the supervision. And it is same as when a student learn things in the supervision of the teacher, as I have already told you. So the whole concept is matching with the real life scenario in which your teacher is training you. Okay, so there is this example of supervised learning. It is known as the spam filtering. In case of sometimes when you get the emails, what happens? Sometimes your emails go into the spam. So why it is going to the spam? Because there is some criteria, there is some supervision that for getting your mail into the inbox, there is some criteria that it should be virus free. Okay, so there is a supervision that it should be virus free, but whenever the virus is available, so it automatically shifts to another folder which is known as the spam. Okay, so this is not that one valid example, but when we will do the linear regression, because we are not working on spam filtering, we are working on linear regression. So your linear regression will better explain you about the supervised learning. Okay, so there are further your supervised learning is divided into two categories. One is classification, other one is regression. Okay, we will do these in detail. But for the time, I will tell you that in a regression, there are further, it is of two types. One is the linear regression, other one is the logistic regression. We will do these two also in detail. Linear regression is one that we did yesterday, linear model. And logistic regression we will do when we will do regression in detail, and we will also do the classification. Okay, so for the time you should only know. So what are the types of supervised learning? So supervised learning is of two types, classification and regression. Classification has its own further categories. Regression, like it has two categories, linear and logistic. Okay, after that there is this unsupervised learning. So your unsupervised learning, it is exactly the opposite of your supervised learning. Okay, in this, your machine is learning without any supervision. Okay, it means in classroom, if you are learning by your own, you are not getting the help of your teacher or supervisor. Okay, it means you are not under supervision, you are learning unsupervised way. Similarly, sometimes there is need that your machine should also learn in the way that there is no supervision available. So that category of learning is known as the unsupervised learning. Okay, so the training is provided to the machine with the set of data that has not been labeled. Previously, I told you that we provide it with the labeled data. Okay, so unsupervised learning doesn't completely mean that there is no supervision. Yes, there is some data available, but that data is meaningless because that data has no labels. You are feeding numerical data into your machine without any label, so that data actually becomes meaningless, but still there is data. Okay, that has not been labeled, that has not been classified, and that has not been categorized. Okay, the data is without classification, without any category, without any label, and the algorithm needs to act on that data without any supervision. It means you will not get the data, sorry, the labels, but your algorithm will only work on the data. Okay, so it will work on the data, that this is the data without any labels. So it will find the pattern in the data only. It is not mentioned to the machine that this data is area, this data is price, nothing like that. It is not categorized as area and price. It is not labeled as area and price. It is not classified as area and price. I am just saying these three words just to make you learn. Okay. And then using this data and its pattern, your machine will start making its own supervision in the absence of any labels. So unsupervised learning doesn't completely mean that there is no data available. Yes, there is data available, but that data is not labeled. That's why it is known as unsupervised learning. Okay, so what is the main motive of this? The main motive is that you now have data. You on your own, the goal of unsupervised learning is to actually give it a structure. Give structure to your input data, give it new features or a group of objects with similar patterns. Okay, so suppose the machine is learning, I'm giving it the data only. Okay, and there is some data already into your machine. For that data, some labels are being assigned and the categories are being assigned. Now what will happen? Using that data, which is the labeled one, your machine will decide that this unlabeled data should get what labels. Okay, so it is matching the pattern, that this pattern, this kind of data comes earlier or not. If this type of data comes earlier, what was the label? If it detects the label, it assigns the same label to this data also. Okay, so in unsupervised learning, we don't have a predetermined result. We don't know what will be the actual output. The machine tries to find useful insights from the huge amount of data that you are feeding to it and that is already available. So it is struggling with it. Okay, so supervised learning is obviously better because you already know what will be the label of the first one, what will be the label of the output. But in case of unsupervised learning, you are just feeding data. You are not giving it label. The machine is struggling. It is getting the insights. It is getting ideas. It is detecting the patterns by comparing the data already available with the new data. Okay. So sometime it will be able to predict the output. Sometimes everything will go in a waste. So like supervised learning was of two types, classification and regression. Similarly, unsupervised learning is further classified into two categories. One is clustering and second one is the association. So in part A of your syllabus, after covering the types of your machine learning, we will do all these techniques one by one: linear regression, logistic, classification, clustering, association, and their algorithms. And we will use sample data to run these algorithms, okay, in Python. After that, we have this third category of learning, which is known as the reinforcement learning. Okay, so it's actually a feedback based learning method where you are continuously getting the feedback. So in case of supervised learning, students' output is already fixed. For this area, this will be the price. Okay, so the feedback in that case is already fixed. But in case of reinforcement learning, it is mentioned it is feedback based learning method in which a learning agent gets a reward for each right action and gets a plenty for each wrong action. So by learning all these three types, you will find that although they are different, but there is some similarity in all the three. The supervised learning, everything is supervised. For input, output is mentioned. That output is available, and whenever you are predicting something, that output is helping you. In case of unsupervised learning, only data is available. No desired output is given, no labeling is given. Machine is struggling by using previous data. It is trying to make the patterns, it is trying to decide the output, but you are not sure whether that output is the exact one or not. As in case of supervised learning, you know that yes, this is exact one. Okay, now in reinforcement learning, there is a feedback available. Okay, so your machine will get the data. Obviously, your machine will always get the data in all the three categories. It will always get the data. It will apply algorithm on it, certain algorithm. Now, there is no compulsion that only one algorithm will work on a data. On a single data, you can apply any algorithm. Okay, so it's not that you are applying linear regression, the data on which we were applying linear regression, you can apply a classification on it, you can apply a clustering on it, but the best suited algorithm will be linear regression. Okay, so your machine, in case of reinforcement learning, will apply algorithms on it, and there is a feedback system, there is a feedback based method that is always giving your machine a hint that whether the output that it is predicting is okay or not. Okay, so if it is close to prediction, it will get a reward. Okay, so what in this case, reward is not that it is getting certain price. So for that, reward means that data, that input and output will now be fed to the machine as one perfect pair. Okay, this is already checked. But if your machine is predicting something wrong, it will get a penalty. Penalty means that set of data will be removed from the machine. Okay, so it learns automatically with these feedbacks and improves its performance. So whenever that data set is fixed, that it is perfect, so it will try to learn, okay, for this input, this output is perfect, so next time I have to predict like this. And if some data sets are removed, so it will consider, okay, so this data set has been removed, it means this output is not matching with this input, so next time I should not predict it like this. Okay, so in reinforcement learning, it interacts with the environment and explores it. And the goal is to get the most reward points, and hence it improves its performance. The more feedback, the feedback is more positive, it means it is improving the performance of the machine. It is negative, it means your machine is not performing good. Okay, so there is this robotic dog. There are robots which automatically learns the movements of his arms, is an example of reinforcement learning. It is making one movement and that movement is not giving it anything. So next time it just don't, it actually your that dog stop doing that movement. So it is learning from it. For example, so suppose that your that dog is spreading the arm to catch something. So it is spreading the arm only to 2 centimeter and it is not able to grab that ball. The ball is away. So next time it will not follow that 2 centimeter movement. It will restrict itself from doing that 2 centimeter movement. Next time it will try for 3 centimeter. So if with 3 centimeter it is able to go to that ball, so it will keep on trying with the 3 and more than that. So it means it is learning from the actions, from its own actions. So after that, we are going to cover the applications of machine learning. Okay, so first of all, the very first application is in image recognition. Okay, so now currently our search on Google is based on the text. We fill the keywords, right? And on the basis of that keywords, it comes up with the solutions and the results that this could be the your search about. For example, if you want to search about certain country, so you give the name of that country into the Google and the Google will give you so many links that you can explore and learn about that country. Okay, but the search can also be improved by using image. Okay, you can input images and on the basis of that image, your machine just go over that image, that what is available, what are the features of the face, and it will help you to find similar images or maybe the similar faces on the web. Okay, so it is one of the most common applications, right? And it is used to identify objects, persons, places, and even digital images. And it is used for recognizing the face perfectly, and it is not used to recognize the places but for the faces. For example, the biometric attendance, in which you just stand in front of it, it recognizes your face, your facial structures, your facial expressions, and it will match it with the data already fed into it, and it will check that whether the same person is marking the attendance or not. If your data is available, your data is a match, so it will mark your attendance. If there is a new person who is trying to mark attendance whose data is not fed, so it will say that data is not, your face is not recognized. Similarly, I don't know if anyone out of you is using iPhone or not, but in iPhone, whatever faces you have in your photos in the gallery, whatever faces you have already, so it will make one grid of it. For example, I have photographs of me with my family members, with certain friends of mine. So I will go to that section where it is just giving me the faces of those people whose photographs I have. It means it is recognizing the faces. So if I will click on one face, for example, I will click on the face of one of my family members, so all the photographs of that family member will open one after another. It means it is applying that face recognition idea. Second thing, whenever you upload any picture on Facebook, I don't know if you have come across this thing, that you have uploaded a photograph with your friends on the Facebook. Automatically the tagging suggestions come. For example, there are 4 people in the photograph. So suppose that I am posting the picture and I have 3 more friends of mine. So automatically it will start recognizing the faces on the basis of my previous uploads, and it will give you the tagging hints. Okay, so the very first face of is this friend, you can tag it. The second face of this friend, you can, and the prediction is so perfect that it never gets wrong idea of the faces. Okay, so Facebook provides us with this feature of automatic friend tagging suggestion in the photos, and whenever we upload a photo with our Facebook friend, then we automatically get a tagging suggestion with name. And the technology behind this is machine learning's face detection and recognition algorithm. So it means this is a big platform. Facebook is a big platform, so it is making everything easy for you. So it has applied this machine learning algorithm for you, so that you don't have to waste time to look for your friends and then tag. So it is automatically throwing suggestions. Okay, and obviously this is an algorithm, so some project has been created for it. So the name of the project behind it is Deep Face. Okay, so what is the name of this? It is the Deep Face. And because of that project being created by some machine learning professional, you are able to identify the faces.